Okay. So I think we're on here, and we did all of the College Board scores, and then we were on the nursing coding data, and we were going to do the simple frequency distribution. That's where we left off, kind of like right at the start. So you can go into Excel. Open. So this basically is a frequency distribution. We're going to create one with these scores right here. So you should be able to just grab those and cut and paste them into Excel. That should work, maybe, probably, yeah. If you make your rows longer, those apps, you can just literally cut and paste them. Just don't cut and paste any of like the words around them. That should work for everybody. So you should have something that looks kind of like this. So for this, so you can type simple frequency distribution table if you want to give it a title. And then we're going to put like our score, and we're going to put our frequency. And I can make that bigger. Does that make sense so far, everybody? Just we're cutting and pasting, and then we're going to do scores and the frequency. We're absolutely not going to count these. I'm going to show you a much easier way to do it. So just kind of tell me as you get that much before I do anything else. That's the thing coming up. I'm just making sure you guys get to this point. I'm going to show you that momentarily. Yeah, Carlos. I just highlighted them like from the bottom to like and like highlight them like that. Then I did Control C and then Control V. I feel like if you come down, if you go down this way, or if you go like this, it might like botch something because of like the code behind it or the spaces. I think it's probably that easy, but if not, I can come over, take a look, and or I could read the numbers off if we gotta do it, if you want to do it by hand. And then, like I said, just highlight up through the 72. Don't do like this or like even that space that you see right there. Because that worked for me on this one. So I'm assuming that'll work identical on that one for you. Yeah, for paste. You do Control C. Okay. So then all I've done at this point is just I wrote simple frequency distribution table. I put score. So we're going to see how much the frequency is for each one of these, and then we're going to list a number for the frequency to the right. Are you good, Jonathan? Are you okay? Anybody need to catch up at all? Okay. So then what you can do is you can highlight all of these, and then rather than counting them by hand, because it's so like 2005, you can just do conditional formatting, and then you go new rule. Oh, I know why it's doing that. Okay. I don't know why this is, but if I shut off the projector and I wait like 30 seconds, turn it back on, it'll actually project normal. Like it doesn't even make sense because like the angle is exactly the same, but that's like what seems to happen in this classroom. So. It looks like it's in colors and it's like tab. Yeah. While we're waiting for that, I will see if I can duplicate that over here. So. See, I'm not crazy. It's fine. I did nothing. All I did was turn it on, turn it back off. So you should have that. And then what we're going to do is student resources. You can highlight those. You do conditional formatting, new rule, and then you want format cells only that contain. I'll leave that up for a second so you can all see that and so that I can duplicate that on this side for the screen share. So just get to that point. I did conditional formatting, new, for like a new rule. How did I get this pop up? We can do that again, no problem. Conditional formatting, new rule. Just up to that point. New rule. So animation grades for students, Control C. Where's Excel? Excel. So just new rule, and then we're gonna get the pop-up. Create. That did not move over well at all. Okay. So then you click format cells only that contain. Okay. It should be new rule. Yes. So those are highlighted, right? Where's your new rule? Oh, yeah, you got it. You're just different. So instead of greater than, just take that, make that drop down equal to, like that 41 under cell value. Yep, equal to. And now we're going to give it the number that we want, which is 72. But don't click out of there yet, because we're going to make Excel like work basically like a crayon for us. So there we go. Conditional formatting, new rule. Only cells that contain cell value equal to, and I want 72. Format right here. Want to see the format button? Then you go fill, and then you can pick a color. And then it'll show you that there's clearly 3 of them. Or 4. Technically 1, 2, 3, 4, right? So then you can just go into, so we just go score 72, 4. And then you can just go conditional formatting, clear rules from selected cells or clear rules from entire sheet. Either is going to work. Now it's clean again. So then we just do the same thing, just highlight all that. And then just go conditional formatting, new rule. Only that contains cell value equal to 68. Format, say blue. $68. We have 1, 2, 3. So 68, 3. Makes sense. Now we can also, I'll show you a little trick here. Could also take this right here and just scroll down a little ways and go conditional formatting, new rule, unique format only unique or duplicate values, format, and pick a color. How about red? Okay. Same thing. Now, if we go back up, that's going to do nothing to it. But as we're going through there, let's say we have a list of numbers and we're like, wait a second, how about 72? It's going to do that automatically for you so that we don't end up creating like listing the number twice, if that makes sense, everybody. So then we can take these, we just go like that. And we can do conditional format. Now, if we're going to keep that rule, I would just say from selected cells, not entire sheet, or I'm going to clear the rule I just did to look for the duplicate values. So clear, so we have 81. So you can put 81 right here. Well, let's not do 81 yet. Let's just go like this. Conditional formatting, new rule, only cells that contain equal to 81. And I didn't do that rule right because I didn't grab a color. New rule, only cells that contain equal to 81. Format, color so I can see it, green. Okay, we got 1, 2, 3, 4 of them. Great. 81, 4. Take this, I'm going to conditional formatting, clear rules, selected cells because I have that rule here to prevent duplicates. All right, so we got 58's next one. So highlight that, conditional formatting, new rule, cells that contain equal to 58. Pick a color. Okay, orange this time. We got 1, 2, 3, 4, 5. 58. Frequency happens 5 times. Formatting, clear, clear. All right, we got 65. So grab that. Formatting, rule. $65. That green. So we have 65 and it occurs 1, 2, 3, 4 times. So we have 70 next. So we can write 70 here. That would be fine. Just keep us on track. Go like that. Conditional formatting, clear rules from selected cells. And let's go conditional formatting, new rule. Contain equal to, we're on 70. Format, let's grab color. Okay, so 70 twice. Cool. 2. So then we'll do this. Formatting. Now, technically, if you were picking different colors and you kept track of your colors, you wouldn't actually have to clear the rule every time, but I think it's easier if you do. 83. So we'll take all of these, we'll go conditional formatting, new rule, cells that contain, say blue. Oh, 83. Warning. So what we're doing is we're on the other part of assignment 3 and 4. We've cut and pasted this into Excel and we're creating a simple frequency distribution table. We're making Excel count for us. So once you have this pulled up, I'm assuming you can see pretty well. If you can't, I can zoom in. We're doing this over and over again, so you'll be able to see what we're doing as you open up Excel and stuff. So, and if you get stuck, just talk to us. So 83, that's twice. So we'll do the same thing. We'll go ahead and clear those out. The rule, selected cells. Next one's 74, 74. And let's see how many times 74 is in there. So we'll highlight the whole thing. We'll go conditional formatting, new rule, only cells that contain equal to 74. That did not work, so I need to pick color. So we'll do that again. New rule, cells that contain equal to 74. Format green. Okay. There's only one. Okay. Easy enough. 74, 1. Same thing. Here. Next one's 58. Oh, wait a second. We don't need to do that, right? Because we already did 58, so we'll keep moving. So how about 36? 36. Good, not done that yet, so let's go like this. Once you have Excel, I'll show you the other rule in a set. When just like raise your hand or something, Gustavo, and I'll show you how to do the rule where it looks for, because we're doing rules for it to show us, obviously, but also we created the rules that if I put a number in here that is the same, it'll make it red, so I won't forget. So I won't list the number twice. So a new rule, 36. Format cells that contain equal to 36. Grab a color. Let's say blue this time. Just one. Okay, great. Frequency distribution happens one time. Cells. All right, so our next one, let's start up here, 49. 49. And how times do we have it? A lot of these repeat though, so you'll find pretty quickly you'll start to have to 49. Format. 1, 2, 3, 4. 4 times. Formatting, clear rules from selected cells. Okay, 73. I don't think we've done 73 yet, but we can check. Oh, we're good. So 73 happens. Format blue twice. There's our frequency. Many. Let's do 60. Yeah, all right. Formatting cells that contain equal to 60. Color blue. 60 happens 4 times. Is that making sense? Everybody seeing that? Right, okay, cool. All right, so our next one is going to be 59. With all that. Formatting. Here, cells. 59 here just to make sure we didn't already do it. Looks like we did not. Highlight additional formatting, new rule. Does that contain to 59 format color? Okay. And it's distributed twice. All right. Now I know we already did. Is everything working, or do you want me to come around, Gustavo? So I know we already did 60 because I can see it right here. But if I typed it, this would become red because of our rules. So we know that we don't want to do that again. So we'll just move on to the next one, 93. 3. And for the other rule, Gustavo, if you take and you highlight just like a ways down, just this one column, you're right. And then if you click on conditional formatting, new rule, and you do format, we did format, unique or duplicate values only. And then we said, make it red in that column. Okay, so now what happens is, as I'm going through these, if I accidentally type something like 60, it shows that there's, I'm basically telling Excel to look for any duplication. So now we got 93. So you go like this, conditional formatting, new rule, format cells only that contain equal to 93. Let's pick a color, blue. Just once, okay, cool. But then I don't have to go through and count them all because that could be very tedious. Next number is 32. Looks like we have not used 32 yet, so let's clear our rule. Cells, but in an entire sheet, it'll wreck the rule on the bottom. That's why I'm doing the cells. So we'll go conditional formatting, new rule that contain equal to only 32, format green. Okay, just once. All right, that's easy. Next one is 61. Have we used 61 yet? Looks like we have not. So let's do 61. Formatting, clear from selected cells. Rule equal to 61. Twice, easy enough. All right, next one is 49. We've already done 49, so let's keep moving. How about 79? We have not done 79 yet, so we'll do 79. And then clear cells, additional formatting, new rule. We are on 79. Format. That. 1, 2, 3, 4. Okay. Frequency is 4. I don't know, we already did 81, but just for argument's sake, we can just go. So 81 and so we have 81, 79, 52. So 81, nope, that's a problem. 79, nope, that's a problem. Okay. So we just got rid of these. How about 52? Did we do 52 yet? Let's find out. 52. We did not do 52 yet. All right, so 52 happens how many times? So formatting, new rule. Cancel. 52, format. We have 4 times. 1, 2, 3, 4. So 4 times. All right, our next number is 48. Not done 48 yet. Cool. So we'll just go like this. Formatting, clear cells, and new rule. Cells that contain 48. Color green. Okay. Twice. Okay. 2. All right. And that. Or you could count them, but that would just take forever. 69. 69 yet? Yeah, we have not. Okay. So let's go. These. Rule. 2. 9. Format. Just once. Okay. Easy enough. 1. Next one is 39. I don't think we've done 39 yet, but we can check. We have not. So 39. Formatting. Equal to 39. Green. 1, 2, 3, 4. Yeah, pretty easy. 4. Next number is 49. We did 49 yet? I think we did, but double check. Yep. So we're going to skip that one. Next one is 89. Did not do 89 yet. Okay. So that formatting, clear cells. Rule. 89. Twice, okay. 2 times. 72 is next. We do 72 yet? We did, so we're gonna skip it. Next one is 81. I think we did 81 already. All right, yep, we did, so we can skip that one. 63, we do 63. Not do 63 yet, all right. Easy enough. Formatting. The rules, cells, we're gonna do 63. 1, 2, 63. Format. Go. Twice, okay. Let's do clear. Clear selected, and our next one up is 52. Did we do 52 yet? We did, so we're gonna skip that one. All right, 43. Did not do 43 yet, okay. Cool. Got that. Formatting, new rule. Contain 243. Oh, just once, okay. No, all right, what's our next number? 52, I think we did 52 already. Yep. Next number is 71. Not do 71 yet, so we're right here. So we'll take all that. Formatting, clear. 71. Rule. 2. 71. Format. Twice, okay. Formatting, clear. Okay. 88. Did we do 88 yet? I don't think we did. We did? Nope, 88. Okay. Rule. How many cells I contain equal to 88. Format. 1. Okay. Formatting, clear rules, selected, 90. All right, did we do 90 yet? Did not do 90 yet, so let's see how many times it occurs. 90, conditional, new rule, cells that contain 2, 90, format, color, okay, okay. Only happens once, all right. Distribution, easy enough, 39, I think we did 39 already. We did, so we're gonna leave 39 alone. 42, didn't do 42 yet. Did not do 42 yet. So take this, conditional, clear, select cells, conditional, new rule, contain 242, format, color, okay, just once, okay. 29, do 29 yet? No, okay, cool. But we definitely did 72, so we're just gonna do 29. Here. Additional, new, cells, equal, 29. Color, just once, okay. I know we did 72. I could check by typing it here, but it's going to turn red immediately. So we'll leave that one alone and we'll go to 31. Formatting, clear, clear, 2031. One format. Just one time. 31. 56 yet. I feel like we did. Let's double check. No, we did not do 56 yet. Okay. So we'll do 56. Clear. Additional rule equal to 56. Format green. Okay. Twice. So it's distributed twice. 38 is next. Did we do 38 yet? Did not do 38 yet. Okay. Easy enough. So we'll take all this. Formatting clear. Formatting new rule. So 38. Okay. 2. All right. Easy enough. We did 89 yet. We did. So we're going to skip 89. 75. I don't think we did 75 yet. 75. Here. Twice. For just simple frequency distribution, basically a table. I'm gonna make it we're gonna make it a little more fancy when we finish. But that's so 62 is next. Did we do 62 already? We did not, otherwise it would be red. So we'll take this. You know what I'm gonna do? Simple frequency distribution table. Say score. I should go just to take these and just move those. So I think that'd be easier to see for everybody. See. So 62. Okay. It didn't really help at all. So we'll just not do that. I just thought it might be easier for you to see. All right, 62. Clear. Additional new cells that contain equal to 2. Two of them. Great. Distributed twice. 57. We've got 57. Let's see. 57. No. All right. So we'll just go like this. Additional your rule. 2. Around 57. Format. Just once. Okay. 39. Well, I know we did 39. Yep. So we'll skip it. 70. We do 70 yet? Good. Okay. Great. How about 65 and 58? I'm pretty sure we did both of those. 65. Yep. 58. Yep. So we'll skip those. So now we're on to 92. Did we do 92 yet? We might have. 92. No, we didn't do 92 yet. All right. So we're going to go like this. Formatting, clear. Formatting, new. Let's cells that contain equal to 92. Color just one. All right. 92 only happens one time for our frequency. All right. So how about 45? 45 did not do 45 yet. So it will show me everything that is 45. Just once, okay. 58, 73. I think we did both of those, but we can check 58. That's a problem, so we're going to skip it. How about 73? That's a problem, so we're going to skip it. How about 94? 94 yet? Not to 94. So we're right here. Grab that. Conditional formatting, clear, conditional formatting, new, contain, equal to 94, format, green, okay. Just one, okay, 91 would be next. So 1 and 91. It's not 91 yet. New, show me all 91s. 91. Just one. Distributed one time. All right. 66, 76. 76. 76. Okay, we can do both of those because we have not done that yet. So 66. Here. 66. New. Equal. 66. Once. How about 76? Here. New. Just once. Okay, great. 65 from 40. I think we did 65 already. Yep, how about 40? Did not do 40 yet. Okay, easy enough. So we're right here. Got a few more to go. 40. Clear. Selected. 2. 40. Twice. Okay. So our distribution of 40 happens 2 times on our table. Let's take that. Additional formatting, clear, entire sheet. Get 83 and then 60. So did we do those yet? 83 and 60. Okay, we have not done either one of those yet. So let's go 83. Formatting, rule, contain, equal to 83. Format. We did do 83. I didn't. Oh, you know what happened? My rule ran out. My rule should go further. That's why there's a problem. So let's fix that. Conditional formatting, new rule, unique or duplicate values, red. Okay. Okay. Now it'll tell me. Nice catch. Yeah. We can't do 83. We can't do 60 because we already did those. Okay, there we go. All right, so we did those two. 60 and 83, so how about 52? We did 52. Not be doing that. So 53, 53 yet. Did not do 53, okay. New team equal to 53. Additional rule. Three format. One. All right. Another way to make sure you're doing the rules, you could like highlight the whole cell like that, and then you can do new rule cells that contain unique or duplicate values, format red. And then it would be the whole, if I move those into that column, it would catch them. So 53 one time, let's see 20, I think we did 28 already. Oh, no, we did not, okay. So we'll take all that, initial formatting. Excuse me. Ink. Cancel. Equals 28. Format blue. Just once, okay. One time. All right, 65. I think we did 65 already. Yep. I missed 77? Or is it coming? I'm in H. Did I miss 77? Did I do these ones already? Oh, we can check. 38, 54, 79. 38, yep. 54, no. 79. We did do 79. So 54. 79, we did 77. Did I skip a row? Sorry, guys. 77. 77. We could actually just take seven. We can take the rest of them and just find out. 77, 59. 59 already. Yes, we did. 9. 61, 39. We did those two. 61. Yep. 39. Yep. 68, 56. Yep. 6. Yep. 49, 46. 49. 46 we did not do. And that takes us back to 28. So we can do 65, which I think was already there. Yep. 48. 48. Yep. 37. 78. 58, 68, 63. I think we did those ones. 58. Yep. 68. Yep. 63. Yep. So we did those. 67, 75. 67, 75. Nope. Just the 67. All right. After 75, 79, 67. 79. Can't do that one. Can't do 67 because I'm looking at it. So that one's repeated. 71, 60, 55. I think that's it. 71. Yep. 60, 55. Yeah, those are all there. 60. Yep. 55 is the last one that we don't have. So that's the remainder. All right, so let's find 54. Did I miss anything? Anybody? All right, so control, clear, and we are on 54. Yeah, that's what I thought. Conditional formatting, new rule, cells that contain equal to 54 is in there once, so just going to distribute it one time. How about 77? Formatting, clear. Should just be in there once, but we can check. Equal to 77, format. Just once, okay. 46. Formatting, clear. Clear. Formatting, new rule. Format only cells that contain equal to. Is it 46? Right? 46, I think. Format. Green. Yeah, just one time. So one time. 37. I believe these all only repeat once at this point, but we can make sure Excel tells us so that we're not messing it up. So clear. And we're on 37. Additional new rule. Equal to 37. Again, just once. So we're going 1. We have 78, 67, 55. So those should all just be 1, but rather than guess. 78, right? Yep, 78. Additional formatting, your rule. Two. Later. Just 1. All right, so we got 67 and 55 left. So 67. Additional, clear, clear, new. Equal to 67. Twice. Okay. And 55. Formatting, clear, clear. Formatting new rule. Only cells I contain equal to 55. Format blue, just once. 55. Should be all of them. And then you could just highlight this right here. And then you can just go right here. And you just say, how about all borders? Now you have a simple frequency distribution table without counting by hand. Probably wouldn't have this much data in a different assignment. Does that make sense, everybody? So straightforward. I know it's a little tedious, but that's how you can get there without having to count by hand. You could if you had wanted to. You could have like printed this out and like color coded these or something, or highlighted them and counted them by hand. I was just asking Excel to help us take a shortcut. So it has us do that. 3 simple measures for central tendency, mean, mode, standard deviation, and then variability, range, standard deviation, and variability. So let's do that. So the first one is mean, mode, standard deviation. So, and we're talking about, just for clarity, we're not talking about the frequency, we're talking about the scores, like the numbers, just in case if anybody was wondering. So let's start with mean. Does anyone know what the first step would be for the mean? The sum, and then you divide by the number of scores that we have, right? So let's So let's just start with the sum. So I'm just going to highlight all these right here. And then I'm going to take and I'm going to hit my auto sum. And we should have a number. This would be our total of the scores, or total scores, would probably be the easier way to label it. Sense? Now we need our n because we can count these by hand, but that's kind of a pain. So what we can do, if we want to know what our n is we could just take equals count. Now it doesn't matter which one we do. We can do the left or the right column. We're just asking how many columns do we have of numbers. So we could take all of these, or the column to the right, wouldn't matter, and then go like this. So we have 51 numbers. Does that make sense, everybody? So if we want to get our n or our numbers, we can go, we take, that's because of the rule, by the way, equals count, bracket, and then you want to count all of the numbers on the left or the right. It doesn't matter because we're just saying how many are in the column. And then once you do that, it tells you 51. So we're just saying it. Now, if you count these by hand, if you go 1, 2, you should get 51.
Yeah.
So now we know that, remember, it's the sum. It's the sum of the values over n. Well, we have all that. 3154 divided by 51. That is our mean. So if we tell Excel to do that, we could say mean, and then we could say equals B67 divided by F66. Makes sense, right? So that's our mean. Now, I'm not asking, I'm just saying the mean of all the scores. I'm not saying population, I'm just saying just the mean. So I'm just assuming this is a population. We're using the population formula. But you could also take a shortcut. You could say equals average. And then you could take all your numbers right here. Don't grab the total. And that also give you your mean. That's going to be equals average. And then it's going to be, and that'll tell you. So now, what was that? Yeah.
Like, you know, I think to account the frequency.
We could do a weighted average if we wanted to look at the number of times something is. I believe our directions just say the mean of all the scores. Yeah, simple frequency distribution graph data.
I just took the mean of the raw data.
Yeah.
And I did that to define.
Did I do that wrong?
Because like you only
I added all these.
treat them, you don't take into account the frequency. Like how
No.
many times. Yeah.
I'm not. If you took into account the frequency, you do the weighted mean, your answer would be different.
Yeah. So is that fine? Right. Just do that.
Because it says mean. No, it's not asking for weighted mean. I would just do the mean.
I mean, like couldn't you assume though, like take the mean.
Yeah, I mean, you could, you know what, I'll accept either. If you want to do the weighted, that's fine. I get what you're putting down. The weighted is more accurate. So if you all want to do the weighted, we'd have to do where you add each one of them together.
Yeah, I already did this. I just want to make sure.
Yeah. Yeah, I'm not asking you guys to do the weighted mean. If you want, we can do that, or we can walk through it, but I'll take either.
Okay, thanks.
Yeah, just to keep it simple. I think I forgot the graph data. Simple frequency graph data. So what you could do is if you're going to do a graph, you could just grab this right here. What you would do is you just highlight the whole thing up to here, and then you just go data. Got it. I swear it was right there. Home. Oh, insert, and then charts. And you can just tell it you want like a bar. Or a bar graph. 2D, score, frequency, and then you can go simple frequency distribution. You just like that. So you just tell it like the graph that you want, and Excel will do it for you. So we did that. Okay, so we're on the mean. So the mode. So the mode is the number that's repeated the most, the frequency that's repeated the most. I believe it's 5. Like the number that gets repeated the most. So 58 is reported 5 times. So we'd be looking for the highest frequency, which would be your mode, because that's the number of the times the thing happens the most. Does that make sense, everybody? So if I'm eyeballing it, I'm going, I think it's 5. It sure looks like 5. I could do a trick. I could do cell value equal to 5. And I could just see if there's any other 5s that come up. No, just the 1. So the frequency, the number of times, so we know the mode. So we have we can actually take the table, we can move it if we want to, like over here. So we can say our mode is 5. Now we can also go equals mode. You can do either dot mult if there's more than one mode, or dot single. They both work. With Excel, if you do multi, what it'll do is it'll list it underneath the column. If there's more than one of them, it'll say like 5 and then like 3 if there was one. So if you wanted to do it fancy with Excel, you could just do equals mode. If you think there's more than one, you do mult. Then you grab your range. I'm gonna grab all these. Actually, guys, it's not, I did that backwards. It's 5 is the number of times, so it's the actual score, so it'd be 58. Because it occurs 5 times. The raw score of 58. Right. So we're gonna take and just clear our rules. Clear. And if I wanted to make sure that was the mode, I can go equals mode dot mult in case there's a multi-mode. And because we're dealing with the raw scores, I gotta take all the scores from the top, bottom, or top, doesn't matter, and go like that. And then it's gonna give us, is that right? Let's try mode.sgnl. GL. And let's see if it works. I mean, we know that it's 58 because that 58 comes up 5 times. So let's just see if it cooperates with this formula. Then mode's not working. What?
Grabbing from that, was asking what there's only one of them on the X or the B chart come up once.
Oh, so it wouldn't, yeah, right. So it wouldn't know. So we could do, you know what, if we want to do mode, it'd be better if we did it like this. If we did the same formula, but we just got rid of where this is. And then if we did this to that, I bet you it'll work. Yeah, see, mode 58. Makes sense so far, everybody? What's the next thing that it's doing? Standard deviation. All right, so standard deviation. So we have all of our X values. So we'll do it by hand and then we'll do it by Excel. It's 10. So we need a break, or do you want to finish this and then we'll take a break? Finish this, then we'll take a break. Okay. All right, so we know the score is the X value, right? So we're going to take X minus M over here. This will be our X minus M squared, right? So let's just do one at a time. So our mean is this. So that means equals E16, no, equals B16. B16, is that right? 16. So that's a score minus the mean, which is H54 minus H54. No, it's not. H56. Oh, H55 or H56. That's why. Okay. H56. Yeah, that's right. And then if we put a dollar sign right here, we should be able to fill down. That work? Fill down. I believe that worked.
I don't have, can you show me?
Sure. So we took B16, which was this number, minus H $56. Now I didn't pull that out of the air. This is H56 where our mean was. So whatever your mean is, if you're referencing the cell, just make sure that that makes sense.
So there's a dollar sign
Before the number
mean, oh, that, the position.
for the position. The only reason we're doing that is it makes fill down work. If I do it without the dollar sign, my formula will still work. That's just B16 minus H56. But if I go back and I put the dollar sign in between the letter and the number, which I think either Jonathan or Nick pointed, I know somebody, one of you two pointed that over here. Then when I take and I say, do the same with all the columns, all the way down for the X minus M, and I fill down, which is right here, it'll work because of that dollar sign. So I'm just trying to save you time. Like you don't have to do, yeah, but
I
Katie.
don't think I have the freedom button. And somewhere in my Office 365 button.
That could be why Office 365 looks slightly different and may not have as many bells and whistles as the desktop. I can look though. Yeah. So I did this. So it's this number minus wherever you put your mean. So make sure there's a dollar sign between when you're doing the subtraction in Excel, make sure there's a dollar sign between the letter and the number for your first formula. So if that dollar sign's not there, your fill down feature won't work. You don't have it, do you, Katie? You can do them one at a time, it'll still work. And then what you do is you take this one, Carlos, and then take it all the way to your bottom. Obviously, we're not doing anything with the sum with that last number. And then just click fill. And yours might look different. Yours might be like on the right, because I think I saw your screen, it was slightly different. And you click fill down, and then it'll do all those. If you don't have the fill down feature, then you're just going to want to do just all your values minus your mean, one at a time. It's way easier if you have the fill down feature. I can totally wait for you to catch up. I can totally do them one by hand if you'd like, just so you're all on the same page before you do anything else. It's no problem at all. How to do mode in Excel, or so mode is going to be equals mode.sngl for the because we're assuming in this case it's a single mode. You can do equals mode. So the Excel formula is going to be equals mode dot SNGL. That's for a single mode. If you think there's more than one mode, if you have something like this bimodal, it'd be mode dot mult or multi-mode. And then what will happen with Excel is if this is the case, it's going to list them in order. If there's 3 of them, it's going to go 4, 6, 7. If there's only one, you won't even see any of this. It'll look just like the single formula. You have the button, but you don't know where it's at. I can take a look. In fact, I'll look. If we can find it on yours, maybe it's the same on yours, Katie.
Yeah.
So then you don't have to do as much. You see where your sigma, yeah, that, what's that, that hammer to the right. Left with that. No, that isn't too good. Okay. No, that's not it. Try the. Try other some. No, that's not it. No, you.
Yeah. we will do-
Or just type, if you have, if you have Office 365, you just type in Google. Auto fill down button or something, and it should tell you that plus 365. If it's there. You can also do it by hand. I can wait for you. It's not a big deal. It's just your volume on the street. Takes one second. And then you check the values, and I can zoom in. I can do that. Oh, different colors. Yeah, you can see them. That works too. I would do the same thing. Here. Those are bigger values now, so you can see them. I'm not sure about the fill down. You have 365 also, right?
Yeah, just because it saves the Google's not going to.
Here's just like-
Yeah. So usually it's in-
It should be roughly right about there, approximately. Yeah, by the way, yeah, if you would ask Excel for a function, it'll give you a list, which is absolutely fine if it's spin up, but you gotta know what you're looking for.
Yeah.
So some of those probably will look like something you've never seen yet, or that we won't cover. Oh, what the heck here? I'll Google it quick one more time just to see if I can find something for y'all. Flash, it might be flash fill. That might be it. Did you find a button? Because then tell Carlos, bro. And Gustavo, if that's the case.
Oh.
You-
It might be it.
Should we all look at Katie's computer? Since
Like,
looking in the back here, where is it?
I
wanna know where it is.
wanted the search bar and I pressed fill and it got me the flash fill, but then I don't know how to give me this thing.
It might be flash. Data,
Oh,
Flash. autofill. Is it autofill? As long as the dollar sign's in there.
Oh, it's under data then.
So it's under the data column on the ribbon guides.
So if I did. Oh, flash. See.
Using a desktop one?
This is
Okay.
where.
So now flash fill will work because you don't need that when you're squaring. You can just flash fill it down.
Like with highlighted.
Yeah, just highlight it. That should work, but we'll check your answers against mine. No, that's not working, because it needs something. So you didn't highlight, that's why it didn't work. I would click out of that. Grab your top value right below x minus m squared and highlight downwards from that number. Now do flash fill. Oh.
have to enter more than one example?
Enter like 2 examples, like 2 squares, see if it does it.
So that should be the same thing here. And it's, if you have to square them by hand, it's fine. I can wait for you. It's no big deal at all. This should be equals x minus m. So this is my d 16 to the second power. That looks like a square to me, 10 times 10. So I'm just going to take these. I'm going to fill my squares down. But I will wait for you all. So this should be this. We're just going to take this times itself. So equals the letter and the number, shift 6 key to the second power. And then just do that for every single one of them. You can autofill that and you don't need the dollar sign. You only, it's literally just equals, like equals D23, for example, second, like that, and then just fill down. Or flash fill, if assuming that works. If it doesn't, it's no big deal. You can just,
Do I need a dollar sign?
no,
Because it's saying it doesn't recognize the pattern.
try the dollar sign then. Maybe it's your version of it. The dollar sign should go between the second value, which you don't really have a second value. So try put it in the first value, like right here. Like that. Let's see if that makes a difference for filling it down. Or use the Excel version, the desktop version, because you should all have that, yeah. Oh, is equals the letter and the number of the column. So like for the first one, it was equals D16 this. So, so this is this value minus wherever I put the mean, and the mean happens to be in H55 or 56 for me. So I said this being my first value, B16, which was this one, minus where I put my mean, which was H56. And then I backspaced and put the dollar sign in there to fill down to say X minus M across the board, value minus the mean. Should I zoom in, Alona? Would that be helpful? That's totally fine. I can. I'm just trying to make it nice, and I don't think this gets any bigger. Sorry. Oh,
Just so I can see it.
so what it is it's equals and then reference the cell, or you can put the full number in. It wouldn't matter. I just think it's easier to tell it to look in the columns and rows. Minus the mean. So you either write the mean in, or you can write in equals. You can take minus wherever you put the mean in your cell. And then for the minus part, if you want the fill down to work, put the dollar sign. So I'm talking about that. And then the other thing that we're doing is just squaring each of the values, just taking them to the second power, which is that shift 6 key. We're looking for this to the second power to square. Jonathan, is it all making sense? Is it all working so far for you over there too? Okay. Okay, we'll do it both ways. Perfect. Does everybody have up to this point? Okay, that's fine. Just I'll wait for you to get there. Then we'll do variance. We'll do standard deviation, variance, standard deviation. deviation. Yeah, it's just variability, standard deviation, and then SPSS. That's it. I think it's smaller.
Oh, maybe because my.
Once you have the values, you want to sum them all together for the sum of the squares. And then we're going to do our formula, which will be, does anyone remember what the formula is for variance? SS by N for population, yeah, N minus one. Before we do that though, some of you still working on X minus M, right? That's okay, it's all right. And then our formula for Excel is variance P. You can do .S, but we're not doing that right now. We're doing just population. If you wanted to check it, because we're just assuming this is the population of them. What was your question? Oh, no, we're just doing the population is for keeping it easy. Oh, so for the standard deviation, it's equals st dot dev dot p, I'm pretty sure.
What values would we be taking from the parentheses up there? Would it be from the chart or would it be from the X minus M?
It'd be from the original numbers,
Oh.
because we're telling Excel to do it, but let's do it by hand too.
Yeah. I did what I had checking.
Yeah. Okay, so everybody's got the X, everyone has X minus M, maybe? Okay, so all we're gonna do is we're gonna sum all the values right here to get the sum of the squares or our SS. So if you highlight them at this point and you just literally just give yourself like one more column and click auto sum. What? Oh, we did, yeah, so X minus M, this is that column. And then you're just gonna square each value. There is a fill down, so you just equals like that. And then if you just highlight them, it should give you a fill down. But your version of Excel is not the same as mine. There should be a desktop version of Excel for all of you. So if you don't like how Excel is working with you right now, just open up the desktop version and then cut and paste what you've done so far into the desktop version of Excel, and you'll probably have less problems and more fill down. And if you're wondering how to do that, you literally could just go over to like your Windows menu, and I believe there's like a search button. It should just be right over here in Office on the right. You can use 365. I'm just saying the desktop version is to be just a little more user-friendly, less cage fighty. So, you know, I'm going to show you that. I'm going to show you that. So I'm going to show everybody how to do that. But if you're behind or you're still squaring, just ask and I'll tell you again, just because they're asking too. So we'll just go over it a couple times. So you want to know how to do it by Excel first, and then we'll do it by hand. We can do it backwards. That's fine. So if we wanted our standard deviation, you can say equals st.dev. And I believe it wants all caps for this one. st.dev.p for population, .s for sample. Yeah. We could do either, but I'm just saying for the sake, just to keep it easy to do the population, but we can do, we can do them, let's just do them both, just because it's, just so we get a sense, okay? Because remember when I showed you how like the sample will be very close to the population on that chart where it would fall. So equals standard deviation population. And then we're going to grab the original scores. And we want all those scores. And then like that. Standard deviation. Wrong. Standard deviation. .dev. .p. That not work. It's supposed to be right. Is that not working? Equals standard. Oh, SD dev like that. .p. There's no don't. That's what was not working. P. And then we'll grab all of these. And if you're catching up, don't worry, we'll go over this again in a second. And then this is our standard population, standard deviation population. If we want to do the standard deviation sample, we can do that too. Standard deviation sample. It would be equals standard stdev.s, and then these numbers, and that would account for our denominator, n-1. And if we go like that, you see they're nice and close to each other. They're not identical sample. If we're population, if we wanted to do the variance, we could do variance, we can do population variance. And we can do sample variance. And that would be equals VAR dot P. And then we could just ask Excel. And that'd be the same thing, equals VAR dot S. And then that would be the sample, which accounts for the other. That's not working. VAR. Oh, that's why. Oh, that's all jacked up. Okay, so we go equals VAR dot P. And then I could say, tell me what that is, Excel. Same thing, equals VAR dot S. That's our sample. So this would be the population variance. The other one would be the sample. No, that was right. Yeah, population variance and then sample variance. So we did population variance twice. Top, there, sample variance. Do it by hand. How's the squaring going in the back? Does everyone have the squares? So once you've squared all of them, sum them together to get your sum of your squares. And then once you have your sum of your squares, you divide it by n for the variance for the population, or n minus 1, which would be what, 50? Yeah, or n is 51, so it'd be, or divided by 50. And then you should get, if you do the sum of the squares divided by n, you should get that number. And if you do the sum of the squares minus divided by n minus 1, you should get that number. It should check out whether you do it with the formula or not. You still want to know what you're looking at. So you do the sum of the squares, and then the square root of that is the standard deviation. And if we're doing, and if you want to do square root, so for example, let's go equals the sum of the squares. So this is this number equals divided by 51. That's my population variance, which matches the other one. That makes sense. Or equals this sum of the squares, that number right there, divided by 50 and minus 1. That is our sample variance. And then if you want to do your standard deviation, population standard deviation, and then sample standard deviation. We know it's the square root for the formula, so we just go equals, and let's start with the population variance. So we go actually equals square root, and then grab your population variance. There's your standard deviation. That does make sense because that was these two match. This one and this one match. That was the Excel formula. And then the other one would be equals your sample variant equals the square root of your sample variance, which is this one. And those should match up. Makes sense, everybody. If it doesn't, talk to me. So we did this, we did the graph data, we did these, we did the variability, the range. So let's do the range. This for some reason repeats, then we'll do SPSS. So the range is the highest minus the lowest number. So what we could do is we could take, and what we could do, no, I don't want to replace. You could take these and you can highlight these, but not the total. And then you can click on data. And then you can look at sort. Expand the section. Sort. I don't know what that 615 came from. Is it 94 to 28?
That's what I'm thinking.
Yeah, that's what I have. Because it put the highest number here, 94. I don't know where the 615 came from. Excel is a little wonky. But in our group, 94 minus. So we know the lowest minus the lowest, largest minus the smallest, or the highest minus the lowest. However you want to conceptualize it. So it's going to be, for that range, is going to be 94 minus 28. Is that making sense, everybody? So equals 94 minus 28. So our range is 66. And that is our range. It didn't like when I sorted it, basically. They're right there. I put it back, but our highest value, yeah, go ahead. Oh, the sorting. So if you take, I'm actually just gonna take and move this because this is, oh, we could just do this. We take all this data right here. And then you can go sort. Cancel. Sort. Largest to smallest. Okay. It doesn't work. All right, so then we'll take this data right here. Let's take all of this and let's go sort largest to smallest, expand this section. Yeah, I don't like it when it does that. That confuses it. So we're just gonna take this and we're just gonna ask it to show us sort. We're just gonna continue with the current selection sort. That worked. Yeah, that worked. It added the number though. 2. But I had 72. I think the values are still the same, but I think we could take these values right here. And just so like Excel doesn't get mad at us, we could just take and move those over here. And then we could take all these values, these are literally the same values. And then we can take sort largest to smallest. So I don't know what's doing with 72 or 28. That's weird because it's clearly 94. I don't know why it's adding the number. We could unsort that. We could also take these numbers right here and we could say, well, it sorted it, but it still put 72 at the top. I don't know what's going on with Excel, but 28 looks like a pretty small value. And then if you look, they're all in order. It's 94. So we know 94 minus 28 is 46. All right, that's what we came up with, right? Equals, or no, 66, 98, 90, is it 90, 94 minus 28, 66. And that's our range. Everything right back there, or is it making sense? So let's see what, so we did that. So we need the output measures for central tendency, measures of variability, and graph data in SPSS. So let's grab SPSS. Yep, I'm gonna open it too. And that'll complete that assignment. And then we'll do probability, a little bit of probability practice. And then chapter 6, clarification. And then if we have time, chapter 7. Just kind of depending on where we're at. It's a 4-hour class. We've only been at it for about 90 minutes.
Okay.
Or we'll just do 5 and 6 and we'll do 7 and 8 on Wednesday. New data set. Open. Now we should be able to cut and paste these directly into SPSS. But if not, you could, if that was bothering you, you could just take this right here, go file, new. In fact, let's do that just for like practice purposes. Yeah. All I did is I just took our data and I created a brand new Excel sheet. That's all I did. I'm just making these columns wider so you can see them. So rather than cut and paste it, because SPS might not like that, you can just get file, save as. Excel workbook, we'll call this SPSS1, just so that it's easy. And then we go back into here, we go file, import data, Excel, SPSS one, open. Just okay through it. Now we have some really nice data, but I don't really like that because we should really only have one column. So let's try that again. Let's go back into Excel. And let's take this data instead, because it's nice, it's in a nice row for us right here. Let's take this data, let's go File, New, and move it like that. We can agree that's the same data because there's 51 columns. File, Save As, Documents, we'll call it SPSS2, just so that it's easy for me to find. We'll go File, New Data, so we have a new one. Then we'll File, Import Data, Excel, SPSS2, Open, okay. And now we have all of our scores here, and we can change this. We can say scores makes sense. Okay. Okay. Can we go back? So what I did is I took. Did everybody have this right here? The frequency distribution table we created in the previous Excel. And you have a list of all your scores and all your values. You could take all that, I'm sure, don't grab the total. And you can probably do Control C. And you can probably just, I think you can do Control V. I think that works. No, it doesn't work. So what I did, I did Control C. So you either cut and paste the values, or I cut and pasted them into a brand new Excel document. And then I saved the document so I could remember what it was, like with a easy title. And then if you go into Excel and you're in a brand new one like this one, you just go File, Import Data, Excel, and then you go and you grab the file that you just created, that you just named with just the data in it, and click Open, and you open the Excel file in SPSS. Just say, okay, don't mess with this part. And then you get a nice list of your scores right in SPSS. Either way will work. And then if you don't like this V1, you just go in here and you can type in scores. And then you go back, there it is, scores. I would be happy to do that again if that doesn't make sense. It's 100% fine. We don't even need the frequency. We just need the scores, because what it's asking us to do, our last thing it says is measures for central tendency, measures the variability in graph data. So all we're going to do now is we're going to tell SPSS, give us our central tendency and give us a graph. And then we're going to have two files that we can save. And then what you'll submit will be the Excel file and the SPSS file for the assignment. Is everybody up to this point, or do I need to go back? It's totally okay if I need to show you again. Okay. I'm coming around. Okay, yeah, so now click on variable view. Right there. So it says the name, type in the word scores instead. And change your decimals to 0. Now click on data. Yeah. No, we're gonna do like 2 more steps. I just want you guys to get it in SPSS. So click on variable, type in scores right there. And then for decimals, change it to 0.
Uniform data. And then you probably want to get rid of that 4 because that's probably not. Use. Yeah. We're not going to save it yet. I'm going to show you at the end. We're going to do like 2 more steps, and then we're going to save all the documents you can submit. I'm going to walk you guys through that. All right, so now it wanted central tendency. So central tendency, we know that's mean, median, mode, right? Variability, that's going to be our variance and our standard deviation, really, when you think about it, or just the variance by itself. So you click analyze, descriptive statistics, frequencies, take your scores and move them with the arrow over here to the other side. So you're just moving those over here. Statistics. What?
All variables.
Just scores. You should have just one. If you brought in the frequencies, that's fine, but we're just looking at the raw data. We're going to tell what we want: mean, median, mode, variance, standard deviation. And just for fun, since we already figured out the range on our own, let's hit range. Continue, and then charts, bar chart, frequencies. Okay, continue, and then okay. And then there we go. Right here, yep. And see, this is the stuff that we just calculated by hand. See how fast SPSS is? We can do that again. I can show you again. So you just want to make sure that if you're in SPSS, you can click on Analyze, Descriptive Statistics, Frequencies. This is going to be over here. You're going to move scores over here. Statistics, central tendency right there. You can click that, but let's not, just for convenience and clarity. And then the variance, standard deviation. I think we should click range just for the sake of watching SPSS do it for us. Continue. So the stats, these 3 and these 3. Everyone see that so far? And then you can do charts. You can tell it history, however you want to do it. I would say bar chart. I think we did bar chart. And frequencies, number of times the thing happens. Continue. And then we say okay. And then it gives us all of that. The chart looks kind of wonk. Yeah, it looks wacky. Let's try a histogram. Analyze, descriptives. I don't like the chart. Frequencies, charts, histogram, continue. Okay. How does that look? Yeah, do a histogram, because histogram makes way more sense. And then if you look, it even tells us our mean right here, our standard deviation, and our N. Once you all get that, I'll show you how to save it, and then you can submit. File, save as. I would call this like assignment 3 and 4. Assignment 3 and 4. Output. I would use underscores. I would be careful using spaces. SPSS, at least with the data, likes to say illegal characters. If you do underscores, it gets you around that. And you're going to save it as an SPV file. Save. Or if you want to be fancy, you can do export. And you can export it as
like a document file, but I would say, just for the sake of simplicity, file, save as, SPV file, save. And then it's the same thing with your actual data file. You can do file, save as, SAV, that's your extension, yeah.
We have to do it this way.
Yes. I'll show you how to do a histogram again.
Last time it cannot be produced. Might have to move everything.
Should. And then just name it like assignment 3 and 4. Data, something like that, SAV. And then you're also going to want to save the Excel file, and then you're going to upload all 3 files into the assignment. Save as type. So data file is .sav in SPSS. Output file is .spv, and then Excel is going to be like .xlxs usually. So you go file, save as, browse, and we'll call this assignment 3 and 4. That Excel or data or frequency tables. Frequency tables and what was and percentages or something. Just label it so you know what you're looking at. That's why I know that I'm looking at the same thing. I'm not, you can label it however you want. I'm not gonna like take points off or anything. If you label it, I just want it to make sense, like assignment 3 and 4. And then what that would be is that what we did today and what we did in the other assignment. Now, if you've done 2 Excel files, that's okay. You should be able to upload multiple files in Blackboard. I have SPS on my computer, so I can read that. Now, if you're ever trying to do anything with data, because some of you might work in data, you never know, and you're trying to move an Excel file into like SPS or something that's just not taking it, your workaround would be save as documents and then save it as a CSV, comma, delimited file. It makes it easier for statistical software to read it than Excel. You don't have to do it for the nature of the assignment. I'm just saying it's kind of like making it like a text file. It makes it easier for SPSS to view it. Still won't work?
I tried moving everything. This keeps up.
Okay, that's fine. So continue. Now for charts. Histograms. Okay. Okay. Scroll down. And it doesn't do it. It's a- Oh, I know what's going on. It's your data. Click on variable view. No, inside your data. In the other file, like behind that file. Click on variable view, and then the data that you're working with, get rid of it's because it's a type of string. It doesn't like that. So make that, change that type into like numeric. And then say, okay, then go back to your data. And then you should be able to create what you want to do, analyze. Just what you're working, so the V1, now that'll work. Yep, that's fine. And then charts, histogram, okay. And now you should know the error message. If you scroll down, it should be there.
Okay.
There you go.
Thank you.
Yep. Yeah.
Somehow I thought that I used here now.
Okay, so click on analyze.
Just the scores. So it's just the scores. I haven't done that. I don't know.
I can do that. What would be better though is if you had all the values in one column.
When I first copied it, included it from Excel, it came like this, all my values came like.
Go into Excel. And you still have a list of them where they're all in one row. So take all your values, just the values, just like that column, and cut and paste it into a brand new Excel file,
Yeah.
just like them in like a column
Oh, just-
by themselves, just like a brand new file. I don't even know if I would do a sheet, I would just do
A new one.
a new file. Just a complete new. I mean, you can keep those open if you want, but I would do. No, that's all right. That's why we have classroom hours, so that people learning. So now cut and paste those into Excel. Just what you've highlighted. As long as you have all your values, that's fine. Just Control Z out of that. So now highlight all those. Just to the 55, Control C. Now go back into your other Excel. Do Control V. Now save that file in Excel. That's something you can find. Okay, perfect. As long as you can find it, perfect. Now go to SPSS. And do File New. New data. Now do File, Import Data. Data Excel is fine. Rather than when you just labeled, say Open. Okay, so close it and then open it. That's fine. Oh, it has to do with because you're using like the cloud or something.
No, it's just.
Now do File, Import Data. And then grab the one that you just, you were able to check this part 3. Open. Just say okay. Don't change. Don't. Just click OK. Whatever's checked, just leave it alone. Otherwise, you can. Now you have a nice file. Now click on Variable View. And then here's the View 1. Change it to like the red scores or something. So you know what you're looking at. Now, yep, numeric. So go back to data view, analyze. Descriptive statistics. Frequencies. Move the scores over with the arrow button in the center. Statistics. Mean, median, mode. Standard deviation, variance, range. On the left bottom there. Continue. Charts. Histograms. Continue. And then OK. There you go. And then just you save the data file and the SPV file. So the SPV is the output, and the data file is that's the data. So
One of the scores.
yeah. So if you go in variable view over there, yeah, go into variable view. Change decimals to 0. And then if you name, like, here it says name VAR 001, just type like the word scores or something like that. Now it's a little clearer. Now click on data view. So just that, yeah, and then just save them, and then upload your Excel files and your SPSS files, and then I'll go do it. I'll help you guys in a second. Absolutely.
So is this one or the one that we've been working on?
One that we've been working on. You don't have to save the one you use to bring in the SPS unless you want to. I'll take it, but I'm just looking for assignments 3 and 4, and what we did today in Excel, and then we did in SPSS. And the data file of SPSS, which is the save file, so like 3 files.
For this,
Assignments 3 and 4 SPSS as well. Just something that makes sense. I'll come back to me, Carlos gets out first.
No, I do.
Okay, so those are all in there. Okay, so click on analyze. Descriptive statistics, frequencies. Move your scores over. No, stats. Statistics.
mean, median, mode, standard deviation, variance, range. Okay. And you, yep. Charts, histograms. Okay. And then just okay. Through there, and now we should have. Yes. Okay, so what the problem is, this is your data in SPSS, so you want to go in and clean your data. Like go, so what are all those, it's like, look at all those spaces. Okay, so see if it'll let you delete that. No, I won't. Okay, can you, so you have that all in a list, right? Oh, yeah, so you clear it? So try clearing it.
Yeah.
Whatever you need. Where's the second?
Yeah, that'll get rid of all your variables. That'll totally work. I think that's why it's giving you a flat. I think that's probably what it is. And then look at data.
I'm just uploading all of
Oh, okay. So see if that works. If not, we can just create some fresh data. But scroll all the way down because it will show you the most recent one. Don't keep going. Oh, it's still doing it. Okay, so open up a new, so put on, you know, how to say the quit SPSS? You can just open up a new file. You just did it. So file new, just a new file. Yeah. So now you have a new file. Now go back into Excel. Is that all you have? Just score? Okay, so highlight all of your key column. Just, yeah, and then just delete it. Okay, so highlight all your lines. So we can just double click these, so that just highlights. Yeah, perfect. Now there is a drop down for lines. It might. What you can do though, it should be way easier. Is just take highlight just your scores, not the total, just everything except that.
Unless you do.
Yep, and do Control C,
True, but I have.
and then do File, New, and Excel.
Black.
Yeah, yep, just brand new Excel sheet. And now you Control V. Now save that Excel sheet as something, file, save as, or however you want to save it, so you know what it is you're looking at. Go back to SPSS, now do file, and then import the exact one you just created just now. If you're using numbers instead of Excel, if you want, but see, yeah, just that's what it is. Okay, so go into Excel. And you file, save as, And then, does it give you a type of way to save it? No. It's because you're using the only group. Down the copy. Okay, so can you open the copy? Just in Excel. Okay, so now your numbers file. Go back to numbers.
Oh, wait.
Oh, that's the right ones. Open that one up in SPSS. Just say, okay, perfect. Yep, perfect, perfect. Now you got those. Now click analyze, script statistics, frequencies. Move it over, stats. Alt, yep, those three for your simple tendency. And then the one over here, perfect. Click OK. Charts, histogram. Say okay, okay. And now you have. It's gonna be like that.
Okay.
I don't know why it's doing that. I'm not sure. I think it's the numbers thing is causing a problem with that. Who else needs help? And it's missing stuff. That's fine. That's fine. I can accept that. Because you still have it on there anymore, so that's fine. Yep, which is, I'll go with access to access to my computer, but make sure but I want you guys to do the SPV and the SAV file. So the data and SPV, let's say that. Like your list of numbers. Go into SPSS. It's right here. And then a window maybe? No, I think it's wherever your data is, the numbers that you have in SPSS to go. I think that's your untitled. So, no, that's Excel. I'm saying the SPSS information you brought in, even though it's just that one column, save that file. That's SPV. So you go, so that's perfect. That's 100% perfect. So go here, click on this, scroll up and show me what you have. The file, save as. That's your data file for the assignments we're looking for. So save it as something you know what it is, and then upload that to. Yeah. Just don't. Yeah, something like that is fine. Yeah, if you want, that's fine. Just something that's clear so I know what it is. And then we want to make sure that you have the extension .save, which it's going to have. So it saves. Yep. It doesn't like some of your characters. So get rid of your brackets and your like fraction.
Yeah.
And now like this. So I'll upload that file too, just so like I have your data file.
I feel like I was here.
So good. So just go to Black. So just make sure, as long as there should be an SPV and say Galaxy SPV file. That's fine. Just I wanted this, but for this one, if it's giving me trouble, I can just say Excel and SPV and I'll put in call it that. But generally, when we're working SPSS, I don't want to do that. Probably not this time, but
That's fine.
SPSS
It makes no sense.
assignment, I want you guys to save the data file and your output file. So next time it'll be like .sav, .sv. But I want that right because technically, pretty much have the data. It's very good. So I reinvent the wheel. Just between the two, yeah. Makes sense? Are you good? Okay. What about you? Perfect. Yep. Yep. So, and then you also want to save your data file as something in SPSS. What is this untitled?
behind it, like this file right here. Then just do file, save as. I was telling Carlos, like, I can take the Excel file and the output file, because we pretty much work in Excel. But generally speaking, if we're in the PSS, I'm gonna say, send me the data.
Real.
What?
I think it's in there.
If we're doing something by hand, I will, but if it's SPSS related, because there's gonna be some times where we're literally just gonna enter it in SPSS and then do some other stuff in Excel. Then I'm gonna want both of those, and that's for me to see, hey, they got all the data entered in here, and they did the output for it. Makes sense? And that's a lot of information. But SAB, yeah. Well, I wouldn't call it output, I would call it, you know what it is. And we're gonna get more compliant. It's SPM. I would call it assignment 3 and 4 or something. As long as you're able to find it, I'm pretty chill about how you name for your naming convention. But I would encourage you to like tie into the name of the. You can do that, but don't do that by SPV. Because if you do like 2 extensions, SPSS kind of like doesn't like that. I think it's. Are we 100% good? Save, yeah. And then just submit all 3 files: Excel, save, the save file, and the SPV. In classic good yeah. And then under infographic, just scroll down a little further. Infographic, yep, right there. And then you should be able to just grab the different files and upload it. It should allow more ones. You feeling good about SPSS? Okay, cool. Okay, cool, cool. And then, yeah, there you go, there's that file. You might have to do them one at a time, but it should let all, as long as you do that submission, it should let you. That's perfect. And then there should be like the Excel file. Wherever you would have saved that. So you might have like 2 Excel files, you might have one. How you did it. So if you have today and. If these are all in one, it's 100% file. Just do that. Maybe or download the copy, and then just make sure you upload. Then you upload that as well. Yeah, 7, 3, 4. Perfect. Yeah. Yeah, that easy. Yeah. I know it's a little sarcastic.
I don't know.
That's okay. That's all right. I know it's a lot of. And you're good, right? All 3 of you. So, front row, you guys are.
Yeah,
Does everyone want to take a few minutes?
please.
So we'll take a few minutes, we'll do some probability. We'll come back.
How many?
How about?
No.
Let's say, let's see. How about like 20 after? It's like 9 minutes. Do you guys need more? You guys want 10 or 15? Speak up. How about we say 10? We say a solid 10, 21 after.
Thank you. Take everything.
That's all right. And the Bonita Bowls, it's pretty awesome. Starting in Glen Ellen. It's like $7 to like $12, and they put a bunch of fruit. You missed the meme this morning, Jonathan. Is that awesome? if you work in the corporate world, kind of true, you know? Yeah. The exam's supposed to be Wednesday by midnight, 2 attempts, limited time, hit the highest attempt this Wednesday. Because I announced it last Wednesday, so I was gonna give you a full week. Go ahead.
Yeah, I wasn't sure if it was like, I got the due date, I was like, if I missed it.
No, I'm saying by 11:59.
Okay, yeah,
And the whole idea was that between the reviews we did and having 2 more classes, if you felt for any reason you were really stuck on something on chapters 1 through 4, we could address it before you got to the exam. It is open book, it is open note,
yeah.
it is a limited time. What you can't do, and I can't stress this enough, don't log into Blackboard and then hang out with a friend or your partner or play video games. Like, do it in one sitting or Blackboard will log you out. And I expect you guys to be adults and be responsible. So like, if some random thing happened that was beyond your control, you could talk to me. I would work with you, but I'm not going to give you a bunch of extra attempts because you can't be a responsible adult. Just do it in one sitting, you know? And like I said, it's the highest score. So, but test 2 will not be the same questions. It'll be content.
Is the exam one still due tomorrow?
Hmm?
Is the exam one still due tomorrow?
Exam 1 was going to be Wednesday by midnight.
Oh, not today. I thought tomorrow was Wednesday for some reason.
No, tomorrow's Tuesday all day. It's all right. It happens.
I don't know.
Yes, that is it. Okay. Should be. No, it's not. Part one and part two, okay. We're gonna go edit. Homework.
No, not sure.
Everybody ready to jump back in? Okay, so what we're gonna do, a little bit of work on our own here, but just to really clarify probability, and I'll come around and assist you all, and then we'll probably do like, maybe like a round robin, working groups, partners, on your own, however you want to work, in-class activities. And we're gonna go to part B and chapter 5 review. And I want you to do part 1 and part 2. I don't want you to do part 3 yet, because that's chapter 6. Just do part 1 and part 2 based on the data I'm giving you in the chart and probability. When you do your own, you might want to think about the additive rule or some of the rules we talked about and mix it up a little bit. Does everyone know what we're doing? Does it make sense? In-class activities, and then it's going to be today's date. Homework 6/27/22, and then you should have a worksheet you can download. Just part 1 and part 2. That's probability. Don't touch part 3 yet. I'll help you make heads and tails of part 3 before you have to turn it in, because that's definitely chapter 6 stuff. I'll give you like 10, 15 or so to walk through it. If you need a little more, a little less time, that's fine. And then just ask me questions and then we'll talk through it as a class. Remember, probability, it's the, frequency of the value divided by all of them. So that's our equation that we're using. And then remember, there's different types of outcomes you can think about when you go to your, when you work through your own here. Whether you're talking about conditional, complementary, independent, or mutually exclusive. Not possible. Let's see.
Well, then without something being- because we- Or if it- if it's given us a clue that they
So we can make it like this. X. Yeah. So male. That's- So male lady, so 33 divided by 55 because we don't have males that are in athletics. It could be in other stuff. Oh, give me these athletics. Well, all, wait, all the males 33 divided by 1. It could be everything. That makes sense, yeah. Yeah, because we're saying that he, well,
He could take any of those or just give any, so it doesn't say.
given he's in athletics, so
given he's
so it'd be
in it.
out of everybody that's in athletics. That would make sense. Oh, I got you. Actually, technically, the first one would be out of
Oh, I
all the
totally read
males,
that wrong. I thought it was-
athletics would be 33 out of 182, that's right. And then the only would be the other way.
Yeah.
Yes, that's right, yeah. Yeah, so you have to be really, so whenever you're dealing with probability, you really want to think about like,
Yeah, because that's
what
now-
group out of what group it's really asking. Yeah.
I might not.
Yeah, that makes sense.
This is so confusing.
Sense so far? So for the male participants, you're gonna say, go back up. So out of all the male. So it'd be 33 out of 20. Be 33 out of 55. Because all the people. Wait, no, wait, hang on, a male participant, no, sorry, a male. So it'd be 33 out of 192, because it'd be out of all the male. Because there's 192 males. So, no, hang on. No, 33, 387, because that's everybody. That's everybody, yes. 387. So that's everybody.
No one's asking like. do
And
they-
these males are 20s.
The selected class.
Given that what I'm doing now,
So it'd be
But it's just
54
weird 'cause
out
they're
of
like that.
108,
I'm only looking at the other-
because we're saying grab the male out of all of the student politics.
Okay, so not
Sample
the
space.
complete,
No,
okay.
because we're not saying they could be in multiple groups. So
I got
whenever you're
this
thinking of
one,
the frequency, you
and
really
then
want to go like what it's,
it
what
was-
you're trying to pluck that out of, I guess it's a little sample space. So, right. What's going on here?
Oh, I read academic.
You like go through that already?
Just put that.
So
I'm also working on something else right now.
you should really.
So when do you want?
Because I'm gonna,
No,
this
that
will
would
probably
be
be today,
33 to 55.
I could, because
Number
I'm gonna walk the group,
7.
walk through that. So the first it's like, you talk, and it's really like, what's the frequency of the sample size? And then you go with your own, and I'm challenging you guys to use those rules, like the additive rule, multiplication rule, so go with like, so I gave you like 13, and then come up with 13 of your own. Using the data, and you, what was that? Yes. But you can use the data that I gave you, so there's definitely more combinations than just what I gave.
Crazy. I overthink these conversations.
They're very similar, but then they're asking. for different
I know.
So you want to.
What, 98? Yeah, I do. Oh, 108.
You want to do a couple things?
Yeah, can you?
Yeah, absolutely.
Because he's a, he's a male student.
So.
I don't know if it's, I think, that's the same as. Yeah, it's the same as kind of like number 7. Right, so
male
it's just,
student.
because it's a male student,
Out of
given their
everybody
athletics, you need to find that same knowledge because it's like giving to the student. So it'd still be at a 1. Oh, so you're only one.
They're saying these are politics.
Yeah, same process.
Does that make sense? It depends like how it's worded,
For which one?
like,
So
given that he is a student. So out of all the students that are in politics, what is the chance that he's a male?
It's like, I know it's like simple stuff, but it's like.
How's that? So it's also whenever, so what I always, what I found, I was very frustrated. Like, is if you try to really think of like through the row of like what the two things
That's the part.
are.
Yeah, I know, me too.
Because if you. Actually, hang on. Go back up. Where's probably such a male student, given that he is in politics. Oh, so if we say out of all the male students, we say all the male students, 54 out of 182, that makes sense, right?
Okay.
Out of- We're gonna say
Yes, what is this only?
a male,
Just that section. Yeah.
the
frequency of the thing, which is the politics, out of all the other. No, I said it right. A male student, given that he's in student politics, 54 out of 108, so 50%.
Yeah, okay, so we did it right.
So that makes sense, yeah.
Okay.
But it probably is a female student, given that she is only in academics.
So.
Yeah. Oh, sorry, I'm trying to- So, so I think 5, what I was thinking is, he could be in anything, and then 6 is at their own. So what I'm saying is only it's just kind of a column, but because the male student out of all of us can be named in a group, it would be 4 out of 1.
I know. It's the same word. Same thing.
So,
Okay.
what is, so like, what is probably of the student who is in student politics? So, out of all the students that are in student politics, it would be. So it'd be 108 students total, divided by 3, we get 7 total students. So we're just saying, not male and female, we're saying all the students in the politics, because they happen over the sample space of everyone. Does that make sense?
Yeah, so this answer is.
I think that is, was probably something male students, given that it is a student politics.
Sure.
Yeah. Out of all the male students, what is probably studying him in student politics before I won.
Why is that?
28, that makes sense.
70? Because, so, what is the probability? Actually,
52, because we're saying only academic.
it might be okay, it's about-
We're saying she couldn't be in any other group, so think about like the frequency of groups they could be in, or if they could only be in one, that would probably.
Okay.
So male student given that he's in athletics.
I don't know, we're gonna just- 35. Or 33.
33.
Okay.
Right away. So wait, did I say, oh, did I say only? It's that it's any male student should be 33 out of all, right?
Oh, okay.
That's
So 33
33 out of
out of 192.
192, because I'm saying. What's probably getting a male out of all of them? Does that make sense?
That doesn't make sense.
Yeah. That's in athletics. Does it make sense, or you want to?
Yes, I think it makes sense.
So really think about what the question is, what the sample space is, like what the total would be, as one thing is like the frequency, that should always tell you your numerator and denominator. Yeah, no problem at all. Yep. Come on, here.
I don't know. It kind of is. That's confusing. Like the first half.
Okay.
Like number
Because the
9.
number is
So
like
number
they
9.
switch it, like where they say male students.
Oh, I switched it. This is my worksheet.
Oh, but then it's like.
This is the publisher.
Ah,
This- The other one, the first one I think was theirs. So what is a probability of selecting a student who is in athletics given that he is a male? So we want to look at all the students in athletics.
oh, which one is it?
Academics.
Is it athletic? Number 9. So
Nine.
everybody, so we're saying, what is probably selecting a student who's in academics? So I'm going to say, out of my sample space of everybody in academics, 52. And then what type of student do I want, male or
A
female?
male.
So 27 out of 52.
Why? You just said the other way around. But then the other way around. Because it doesn't say here, because it's like.
Oh, and then now it's saying.
What's
what's the
probably
purpose
assessing a male student who's in academics is completely different.
So what is probably, so let's walk through it. What is probably selecting a student who's in academics, given that he is a male? So out of all the academics,
Oh, and then like,
27 divided by 52, right?
so we don't look at the males, the number of males.
It depends on what we're, if I'm saying, pick a male or female out of academics, my sample space would only be academics, but I'm saying pick them out of academics. If I'm saying something like, what are the chances of picking a male in academics out of everybody, then it's the other number. So you have to pay real close attention to like how it's phrased, so that the numerator and denominator makes sense. And I'm not trying to confuse you by any means, I'm just trying to be clear and articulate about it.
What's the eighth question? The eighth is,
Female student, given that she is a student politics.
that would be divided by 1 or 8.
What, yeah, get what out of all of the students that are in student politics, when we grab a female out of them, yeah, that makes sense. Yeah.
So given that he's a male.
He's a male.
Here. What is the problem is that you said like athletic stage, we have 192?
Because we're saying that he could be in any, we're saying out of all the males, right, out of all the males, the one is in athletics.
So it's not. Academic. So it's just two. But that's the same question. Up here.
Wait, hang on, give me that, no. They're backwards. What is the problem with it? Selecting a male, which. So we give that even athletics. So we want a male out of all the students. Out of all students. Athletics.
No.
What was the other? Given that he is a male.
They were 192. I want it to be that row.
It'd be the row.
So
It-
there's 3 out of 55.
Yeah. Which probably is in the student athletics, given that he's a male. Yes, we're saying so everybody that is in athletics. With the, how, it's likely to gravitate a male out of that group. That makes sense. Yeah, so. Sorry. So there's, so what you're gonna wanna do is you're gonna wanna think of like something happening that I didn't give you yet. So I think I talked about like, what I talk about politics and athletics. Did I say anything about Greek life? Probably not.
Did you change it in finances?
And I didn't say anything about, and I didn't say a lot about academics. So then you could say, what's the probability of selecting someone in a student in Greek life who's a male? That's easy. 78 out of all Greek life, where you could say the females, or you could say something, or if you want to be fancy about it and be creative, so you have the rules, you could say, what's probably selecting somebody in Greek life and academics, or who's a male who's in both, and then you can like the additive rule, like you look at probabilities. No, not two people, one person that maybe are in more than one group. Does that make sense? Like, what if we grabbed a male or female that did these 2 or 3 different groups, and then you get the summation of the probabilities.
Oh.
Yeah, I'll pull up the person.
What?
Yeah, so you'd say, what's the possibility of grabbing a male or female in both of those? Not actually 2 people, just like one in more than one group. And then I'll show you on.
All right. Sure.
Is it making sense? Talking to your.
So for example, as you're all creating your own, you have mutually exclusive, independent, complementary, and conditional. If the outcome can't occur together, then you add the 2 together equal to the sum of the individual probabilities, like the flip of the coin. Or you might have independent when the probability of outcome doesn't affect the other, then you would multiply it. So if you want, this would be like more of like your and. So if you want to select 2 people, a male and a female with different possibilities, independent outcomes, they don't affect each other, then you're going to multiply them. Does that make sense? Mutually independent outcomes. So mutually exclusive, they don't happen together. You add the probabilities together. Independent, one doesn't affect the other. So I'm gonna get a female who's in Greek life and a male who's in athletics in Greek life. I'm figure out those probabilities, then I'm gonna multiply them together. Because this is it's the multiplication of the probabilities for independent. So if we select two people, we do this rule. We multiply, or complementary. The sum of all probabilities equal to 1. I would say for what you're doing is probably independent or mutually exclusive outcomes would probably be what you're going to use the most, either the multiplication or the addition. Does that make sense for the creative part, everybody? So think about, it's the probability is going to increase when you have more groups.
Because it's the same as, 8.
You don't necessarily have to use that rule. It's just the idea that you practice, or you think of a couple on your own, like, oh, if we had two people in these groups, how would we get there? Then you'd use that rule for multiplication. Or like, are they independent? Like they don't affect each other, or are they mutually exclusive? Like you can't have both. They're probably independent outcomes.
Oh, we were talking about the first page.
Oh, 1 through 13. Come around.
No, we didn't do that yet.
We're
We're
doing
talking
part two
about
right
the.
Yeah, part 2. Yeah. Don't worry about part 3.
Okay, perfect.
So just, so like, right, so like, look at some groups that I didn't give you, or combine some groups, or think about if you were to select like a male and a female that were in like some different groups. Because obviously if you select them in the same group, it'd be 100% probability, right? If you didn't go from the table, you'd have to create a new set of data, which would give you more work. Not trying to give you more work, just trying to give you enough so that the stuff clicks. Is it working creatively? Okay, we'll probably do like a round robin. If you were asked for, say like
9,
so it's in a row.
27 out of 52. I haven't talked to him about that.
If there's anything weird in. You could ask me 10 questions really fast. That's why we have class.
So I was looking at 9.12 was, what is the probability of selecting a student who is in academics given if he is a male? So then I looked at, okay, like, what are the chances that out of all the kids, we're gonna pick a guy that's in academics? So that's why I did,
Sound.
Okay, wait. So
then that's why I did, I think 27
he's in grade.
divided by
3.
3.
Yeah, but then he's a male student, so.
Okay, I guess I did student. That was correct.
Probably a student who's in
Okay,
academics.
so we're talking about
given that
anybody.
he's a male. So out of all the students that are in academics, sample space, out of males, that would be zero, right? So we want to grab someone from academics, that's gonna be our sample space. And then we'll see how much the chance of getting of grabbing a male is 27 out of 54.
So are they out of
Yeah.
87?
Don't overthink it. Columns and rows as much as you can.
Okay, so then for this one, I think I did the rest of this one.
This is
So
probably-
athletics, so you're looking at that. row.
Given that he is a male.
Given he is a male. So just 33 over.
Yeah.
You
Yeah.
just did a male that's in athletics, but it's still out of.
So we're 70.
No, because it's backwards.
That's what I-
33 over 192. What is probably selecting a male out of all the males, given that he's in athletics. Does that make sense?
Okay. Because I thought these were like the same.
They're not the same.
This is the, well, let's do it backwards. So if I can consider-
This one was
Not like this.
right, but I'm like.
Oh.
So I'm gonna look at all the students that are in politics, and I want to
What is the probability Oh, they're just like.
Yeah, it's 50, which would be 50%.
Given that he is a male.
Yeah.
which is 50.
Yeah.
Because it's half.
So then why did we do that? Why did we do this way last time?
So go back, make sure that I'm, what's probably selected a student who is in academics, given that he is a male, go back up for 9, right? What is probably selecting a student in athletics, given that he is 33 over 55, right? Yeah, that makes sense, yeah, that makes sense. Sorry, I'm not trying to give it to you backwards,
Okay.
I'm just thinking through it, yeah, that makes sense, yeah.
That would be just a category.
Right?
Yeah.
I'm not trying to confuse you.
I know.
Columns and rows, I think about it too sometimes, so that I explain it. right.
I know.
Selecting, they do it in Greek life.
So you're good?
Okay, so we're
I think,
looking
yeah, I
at
think I get one.
Greek life student is 162.
Yeah, I think I do.
And then, and the whole other part too is when you're going through that, you're thinking about creating your own frequency and your own sample space for your numerator and denominator. And there's definitely groups in there that you have used in your data that they gave you. Or you could also think about like something like this, like what's possible is selecting a female in Greek life and a male in politics, and those are independent of each other. So you would take the probability of one and multiply it by the other, and then you get like a combined probability because you would grab it.
Oh.
Have more questions?
I had. No, I'm not asking my name. Probably just that it's sort of
Oh, yeah, they did ask that one, yeah.
I know.
So just as you're working through it, to make sure like the sample space, like what it's asking makes sense. And then for these ones, you probably do like independent, I would say the most. Unless you have like something like mutually exclusive. But independent, so like that could be selecting a male in Greek life and female in politics. So you would take your 2 different probabilities and multiply them because it's a product of both potential outcomes. If you grab 2. Yeah. But I can walk you through it. Pretty helpful. The whole idea of creating your own was to walk through like just the basics, the frequency of the sample space, but also to challenge you to think about something like the rules, which I feel like independent or mutually exclusive would be the most applicable for what you're doing. In Greek life, so that would be independent because one would affect the other one. And that would be this multiplication now,
Also, can't do a basic.
I know, I just thought 2 people can do it.
2 different groups. Now, if you wanted to do something like, you want to select
13 questions.
a male who's in, what is, in, or you say, I want to select a male and a female that are both in Greek life, then that would be the combined probability, right?
If this is 2 male and 1 male in this way, 1 female, Greek life, so that we can do it by 1.
Could we just do Greek life?
Yes, yeah, you're getting it. So the idea is that if they don't, if they're independent of each other, you multiply it. If they're mutually exclusive, like they don't occur, like you can't have one without the other, then you add the probabilities.
Since they're the same,
It would really be 100, it would be, it'd be 100%, wouldn't it, right? Because that would be out of the whole sample space. It'd be better if you just like a male in Greek life and a female in academics,
so in that way, it is simply by 1.
2, right?
Multiplied by 25 by 1.
Yeah, because that's a multiplicative rule. So we're saying
Oh,
the outcome of those 2 things collectively is the probability of both.
you say Greek life?
No, I'm just, with my eye, here it is. Male in athletics, female in Greek life.
Are we able to like? Yeah, but I want you guys, it's not just to write them, I want you guys to answer them. too.
Wait, but then how do we know?
Oh, wait, we like average, right? Like we average.
So if it's independent, you multiply them. If they're mutually exclusive, they can't occur without one can't occur without the other, then you have them. So you just have to think about what you're afraid of. If you're like, I can't have a female in politics and a male, they're independent, like one doesn't affect the other, use that formula. If they're mutually exclusive, they kind of sit outside of each other. then you have them. So you're probably gonna use that one, because I think most of these are probably. But if like you wanted to select a male who's in Greek life and also in athletics, then you would probably, that would be like the addition, because you have the possibility of the male in that one group in the south space and the other possibility of him being in both. So that's when you would add it. Does that make sense? Because it's complementary. Complementary and mutually exclusive, you add them together. So if you have two kind of like sit outside each other, add them, or if one affects the other, add them. But if they can't occur at the same time, then you multiply the probabilities. So you just have to think about what's happening here. With what you're coming up with. Does that make sense? Or not really, right? I have to.
No, but you have not.
Okay. It's okay. Yeah, because you want so you want a female that's in both. So you're gonna say, so you're gonna take her possibility and it's complementary. She's gonna have both its and. So you're gonna add those two together. Yep. Yeah, and then it would be a collective outcome. You add when they're when they're complementary or mutually exclusive, and you multiply when one doesn't affect the other. It makes sense, right?
For the new question,
The new question, because there's a probability of this, it's complementary, because you're grabbing, it's still one female, but she's in two different groups. So you're saying the possibility of being here and here, you add those together because they are and. When it's independent, it's like or, which is why you multiply. Because they can't, like if I flip a coin.
Wait, 1.02?
You heard what I was saying to them, right? About this rule and stuff. Kind of, I'll repeat it. It's absolutely not a problem. Just keep asking questions. I spent like a couple hours with one of you here on a Saturday, like a couple days ago. So whatever you all need to get you through it, Zoom, face-to-face, in class, out of class, you just keep talking to me. So if it clicks now, great. If it doesn't click now, that's okay. Just don't wait all semester to be like, I was so confused, because that happens sometimes. It's like, well, if I had known, I would have spent the extra time to help you get there. So mutually exclusive, they can't occur together. So the probability of one plus the other is what you do. Or if they're complementary to each other, you add them together. So we're going to select a female who's in Greek life and a female who's also in student athletics. We're still only selecting one female, but we want both. So that's when it's and that's when you add them together because they're cumulative. No, you do it. there's two ways you can do it. You can either sum your denominators and your numerators and just make that one division, or you can do them and then add them. You get the same answer because the sample size increases and so does the frequency, because she's going to be both in Greek life and she's an athlete because it's complementary. Or we select the male who's in 2 or 3 things. There might be 3 of those. If it's mutually exclusive, where they can't occur together, it's the same thing. So if we said, give me a male in Greek life and a female in student athletics, you would still add them together. So mutually exclusive or complementary, add the possibilities together. When it becomes or, because I can't flip a coin twice, like I can't get heads and tails, that's when you multiply. So the way you might write that is, I'd like to select a female or in student athletics or Greek life. Because you're going to multiply because it's independent, one doesn't affect the other. You add when they're either like they can't occur to you add when they would either be like they cannot occur together, or if they affect each other. When they're separate from each other, you multiply.
Okay.
So you just have to think about how you're framing it up, which one you would use. Does that make sense? Okay.
Wait, isn't it- Four? Oh, really, male, not female.
So he's there in 3 stuff. That's my second question.
7?
Yeah. Six questions, probably female athletes and male in Greek.
Oh, so it's 4, but no. 3, but 4? No, wait. Female and
Female in academics and male. Female in academics and female. So she's in 2 classes.
So it's a complementary.
4.
Yeah.
That's 4.
So like if you know, in academics,
4 is male in athletics, female in Greek.
I think our questions are off.
I know, I'm just writing what I created.
You can write whatever you feel like, just make sure you're applying the rules correctly. Like it's just gonna be this. And then when you have multiple probabilities, either add or multiply depending on what you're dealing with. When it's or, multiply. When it's and, add.
Your numbers are off. My numbers are.
Do the rules make sense to you? What, like when you multiply, when you add? When you
That's why
multiply
hers are, she's an extra one. Of
oh.
Okay, if it makes sense, then I'll just take your word. If it doesn't, you gotta tell me, but if it's still super clear, to you also. Okay, cool.
That's our 3. That's 4. Okay, so.
And Greek life, and athletics.
I'm not gonna take it.
Yeah.
And an ale. And academics, so that's and. So that would be additive. If it was an or, it'd be multiplicative. Because the additive rule is they're independent of each other. You can't
Two
like,
different, right?
you're like the male and female in different groups.
The male and
You're gonna
female
add
side.
these, they're independent elements. You're gonna do probability 1 plus probability 2. And then, go ahead, yeah. So you would have, you would do 3, you would do female athletics plus male and male is academics and Greek life. You can absolutely do that question because you would have, everything, they're well, complementary you add them to. Complementary, one affects the other. Yeah, as long as it's not or, then those are all, those you would add like those.
Okay, so I was thinking female multiplied, female and added to academics. Multiplied by 2. That answer and this answer plus.
Well.
Because if I wrote here. Male and athletics.
You have to change this to 4 to multiply.
Oh.
That's the only problem, because if you're adding them all together and they're independent of each other, you add them.
Okay. So, okay.
Or if they were multiple, well, they're complementary. Sure, I'm just saying that. They're complementary.
Yeah, complementary, add, when they're mutually exclusive, add, when they're independent of each other, multiply. So if one doesn't affect the other. So let's look at that. So are they,
27.
if they're independent, are there also the probability of A times the probability of B times the probability of C? Probably both. The outcome 1 does not impact outcome 2.
But this guy is an academics and
So
that's the addition.
so that should be the addition because that's complementary because you want a male that's in
Yes,
both.
now I get it.
So you're gonna take your 1,
Multiplied by-
multiply it by the addition of the 2. And that's gonna equal basically your cumulative probability. Does that make sense?
Yeah.
Okay.
Thank you.
Yep. We're in part 3. Oh, I can go over.
Read 13 questions.
Right, I'm
Yeah.
on the 8th
Don't worry
question.
about part 3 yet. We haven't gone to chapter 6. That's the Z-score table. So let's look at both ones. What is it?
6. But I sent you 1 through 6. In your lessons.
Oh, yeah, you sent it to me already?
As the ones you need to know.
So is that's not an independent outcome,
In your outlook?
that's complementary.
Oh, no.
So you add the possibilities together. Is there, if you say or multiply, you say add, you say and add. Right, this has got to be a goal, so it would literally be both fractions added to each other. Or if you want to be fancy, add your numerators and your denominators together and divide that way. You get the same answer either way. Does that make sense? No, it's gonna be 22 over 55 plus 54 over 108.
Yeah.
All of them in those 2 groups.
You read
right?
great. teacher.
We're not talking about academics or Greek life. For them, or out of all of them.
What's probably something to do on what?
Female is an athletics and male is an academics.
Under male.
Male is academics.
Because
and
the reason you won't play with independent is like, it's sort of that, or it's like, well, we can have a heads or a tails. We can and so whether it's mutually exclusive like cat, or it's complementary, we add, but one has to be or we multiply. That's how you get around it. Or multiply the outcomes and add. And then if you do both of those and you have to think about like steps, like the people in the front row saying, we have 3 different outcomes. So if they start with 1, they add to the other 2. The other 2 are 4, so they multiply 2 of them and they add that. If it's,
Yeah, I
so
hope they're right.
4 is your key to multiply, and is your key to add. Typically, to like simplify it. Those are the rules. Yeah.
When you said good, that's female and male.
If we talk about what we did in about 5 minutes or so, would that work for you all? You need like 10? Try to get to 13. You only got the 5 or 9. How about 10? 10 to 13. All right. The idea is for you to work through it, Ilona, Gustavo, Carlos in the back. The idea is for you to work through it, not take a shortcut. I just wanted to stick. For me, if you did 10 or 13, it doesn't matter if you understood the material. If 13 is going to get you closer to understanding, you should do 13. But if you got it at 10, it's fine. And then maybe I'll show you a practical application of probability, maybe. This might be kind of fun.
probability of selecting a male in academics? Read the question.
Oh, yeah, I'm sorry. What is the probability of selecting a male or a female in academics and a male?
It's supposed to be like two different people. So there's a female in academics. and a male student in academics. But it is one line.
Or multiply and add.
Oh.
Does that make sense? Do you understand like why that would make sense? Because if you're flipping a coin, it can go either way. And one outcome won't affect the other one. They're independent of each other. So that's where you have or. If you have complementary or mutually exclusive, you add them. So if one, like they cannot occur together.
Oh, like the wording.
So like, this is just saying one event, mutually exclusive, they can't occur together, heads or tails. The next one is saying you're doing it twice, you can't have one with the other, they're independent of each other. You have one, you have or, you have flip this lands, or I flip it again, the other one lands, we're gonna multiply. Same thing with complementary. If you're saying someone's in both groups, then you add them, but typically or is your cue for multiplication, and's your cue for addition. Because they're summative, yeah.
I'm still confused. So if I'm finding one student in this area and another student in that area.
And add the you just said
I
and.
need to just multiply.
Multiply when it's or. It depends on your scenario. So or, and I could have said that wrong, not perfect, try to help make it clear for you. I might have said that incorrectly, but basically, like the independent outcome, they talk about the coin. There's two things we're doing, one that doesn't affect the other. So for the sake of argument, if you wanted to recruit a female from athletics or a male from Greek life for one reason or another, maybe that person's going to student politics, but you're saying we want one or, well, because the female and the male wouldn't affect the outcome, that's when you'd multiply. If we said, hey, we want both, then you'd add them for the probability, because the frequency would increase because you're selecting two people. Or you can even say a male from this and a male from that. It's a cumulative probability. If you say I want one or the other, then you multiply it.
So if you have like a female in academics and a male in Greek, you'd still, yeah,
Yeah, because the sum of
right.
the sum of outcomes. So that equals all of them. But even if you're saying they're mutually exclusive, you'd still add them. If you're because you're saying we can have these two different outcomes but they can't occur together. So we're going to add them. It's only if you were saying they don't affect each other. We want one or the other, then it's independent. That's when you multiply.
I changed.
Should we say about 20 after? We'll talk about maybe the first 13 questions you have and maybe share some of the ones you come up with and how you got there. And then I'll show you how cool probability is.
So then for there is another one, what is the probability of selecting a female in female Greek life? Did you change it to two?
Female and athletic.
If you multiply, change it to or. If you're selecting a female in one or the other, multiply. If you're saying you're selecting a female from here and a female from here, then you add. Or even if it's just one female, the fact that she's in two groups, you would add. Okay.
So number one is like, what is the probability of selecting a female or female? Okay. And then that one you brought up to me first.
Honestly, but I choose.
The answer.
It should be 100%, but if you're doing or, because I could, like, you could potentially increase the probability, but because if when you're doing additive, technically the sample size goes up on the bottom and so does X, so you probably wouldn't necessarily get to 1 because it's still out of. When you multiply, that usually makes it go down. It's usually below 100. It depends, but if you had like 3 or 4 outcomes, that could be why. If you, because I think you have like 2 or 3.
I just put a person, one female in all the 4 categories, so in that case, she's in Greek, like she's in academics.
And she's out of all, so you'd have higher than 100%. Usually it's 100%, but if, depending on how you shaped it, it's possibly assuming that your math right.
Yeah, 'cause we got 1.09.
9. What is the approximately female in athletics, Greek life, academics? Wouldn't it just be 100 because it's all the females? It'd be out of all the females. Would it, because you're gonna select a female, out of all, you're gonna select a female on all the groups and all the females, it'd just be 100%.
Yes.
Yeah, no worries.
Mine, 9.
Because you selected, you said you wanted,
She's in all the.
because everything's gonna increase, you're gonna have, your numerator is gonna keep increasing all the way up to your denominator, and your denominator is gonna be out of all. That's why,
The male?
The girl in all the 4.
Yeah, we don't have that.
That's my 9 question.
you don't do the same questions, you can, but you don't have to.
Yeah, we all know different.
Does anyone want to talk about what you have so far, or any questions on the first 13, or any ones that you're brave enough to share with your colleagues that you did and why you did that rule, whether you're talking about multiplication, addition, and why? Maybe some scenarios. How's probability feeling? Clear, unclear? Sure, why don't we do that? Yep.
So, question is, what is the probability of selecting female students using both athletics and student politics? And we got 46%, and that was complementary.
Because she's in both. So when you do the complementary, you can do probability A plus probability B. But technically, because they're complementary, you could just add both numerators and both denominators and then divide, you still get the same answer. Yeah, that's great. Yeah. Another example and or question, let's maybe hear from at least one, maybe hear something from everybody, and then I'll show you something cool with probability. Who's got one for us? Alexa, yeah, you have.
Well, I said, what is the probability of selecting a student who's in athletics and a student in student politics? And I got 42%, and I just added.
Yeah, because you did and should be your cue to sum, or because they're independent of each other, it can be one or the other, should be your cue for multiplication. Yeah. Who else has when they are brave enough to share? Do you have one for us, Jonathan?
Probability of selecting students is in student politics and is also female.
Okay, so that would be addition, the two probabilities, because it's and. Okay, that's what you did, right? You added the two. All right, you got back there, Ilona.
So what is the probability of selecting a male student? What is the probability of selecting a male student in both Greek life and athletics?
So you should have had your numerator, your denominator, and then your numerator, and you added the two together. And the two percentages, because they're cumulative, because they're complementary or independent, it's or when they don't affect each other, and you can only have like one, like two events. So that's, yeah, that's addition. What'd you have, Gustavo? And it's both, so that would be adding. Okay. Okay, I encourage somebody else, somebody in the next couple of folks, or someone we've already heard from, to give us an or example too. What do you have, Katie?
on day five, I got point, or 32%.
32%, but because it was or, she would add both fractions and you would have multiplied them by each other. Because it's one or the other, so it's the accumulation of the multiplication for those, yeah. Colleen, yeah.
What is the probability of selecting a student who is, oh, wait, what is the probability of selecting a female in academics and a male in Greek life? And adding together?
Yeah, because you're adding the two possibilities together, because it's and. So those could be independent or complementary, depending on how you phrase it, it'd be addition. And Nisha, what do you have? Or tell us that really hard one, the three, or whatever you want to tell us.
Probability of selecting female in athletics or male in academics and Greek life. So, with the multiplication of the female with the addition of.
Yeah. Yeah, that's right. So she added two together because they were cumulative. And then the other one was or, which was, I think, the male, and then she multiplied them. And then you have the total possibility. We're usually just doing one or the other, but she's basically saying and, or. So it's add, multiply. Makes sense? Anyone like to see anything cool about probability in math? Okay, probability, all right? This is a brand new deck of cards. This has to do with how awesome probability, math, and outcomes are, okay? I literally have cellophane on it, so I'm not doing anything, but this is literally based on math, because math is cool, all right?
Or Greek life,
So we're gonna take cards out. We're gonna get rid of the crap. Everybody see what I'm doing here? Brand new cards. Do some probability. Let's shuffle them. So random selectivity is 7 times, by the way, for shuffling, in terms of the likelihood of really making them random. So it's 2. Two. 4. 5. 6. 7. Okay. Not looking at them. It's just probability, all right?
playing solitaire.
We're just stacking my odds for probability purposes. So I'll show you in a moment. All I'm doing is counting. Random here. We're gonna have these, okay. So I have 7 piles of cards. You can leave any 3 piles you can take. I would recommend taking away skinny piles just so you don't end up cheating. Again, this is all probability and math. So I have to get on the spot, but you're right in front of me. But Eddie, you can come up here if you like. Leave 3 piles. We have what, 7? Take away any 4 piles you want. Like I said, I recommend taking away skinny cards so that way you know I'm not like memorizing them, but you can take away any piles you want and hand them to me. Or tell your colleagues which ones you want to remove. This is absolutely probability and math that is driving this card trick. I'm not going to show you guys how to do it. I just want to prep the mic and amaze you with how awesome math is. Take away any things that you'd like. Sure. Yep. The last one. That one, okay. So we have 5 left, so we need to get rid of 2 more piles. Okay, sure. And take away one more. Is this what we need? We need a different one. This one? Okay, so now we have 3 files. Okay, now, without, this is literally probability, it's related to clock. I just do a random card trick, okay? Without messing with the order that the cards are in, so we're doing math here, you can move the piles around and I'll look away. So like literally, however you want to do that, just don't start like shuffling the cards because it is math. If you shuffle them, you won't see how cool math is. So want to arrange those? I will look at the board here. Don't be shuffling, just arrange them, okay?
One more to the room.
So are you doing more? I don't need to look. Good. And they're still in the same order.
Yeah.
No, you didn't shuffle them. Okay. So probability and outcomes. I'm going to predict the outcome of one of the 3 cards, not the suit, because that's not possible, just the number, okay? Which card would you like me to predict? This one, that one, or that one, based on outcomes?
Isn't that board number?
They're all different amounts in the files. And you've scrambled them up for me. So which card, I'm gonna tell you what the card is not looking at it based on probability and based on math. I'm asking you which one do you want me to predict? Middle, left, right? This one?
Yeah.
We're gonna predict this card, okay. So we'll overturn those cards. That is 6.
What?
Probability and outcomes. That is completely a mathematically based.
Wait, so then,
That's mathematically based.
what do you do with that? Like, you were counting the cards, you made another
I
decision.
counted a bunch of cards and I used probability to stack the odds in my favor. That's absolutely getting to the outcome of a probability, but I'm using math to drive it. So like, there was counting involved there too.
There's like
That-
36 cards. you counted.
There might have been. There was 50, it only works, you have a full deck of cards, but it was random, but I use math to manipulate the outcome.
So you're not gonna probably do it.
I feel like that I can't drop the mic. I feel like they know tell other students and other staff courses how to do it, and then it won't be like amazing. Hope I just blew your mind about stats, maybe a little bit. The internet might know. but- So before we jump into chapter 6, we can take a short break, or we can jump right into chapter 6. Part 3, we're not going to do yet. We're gonna do part 3 after I explain it. I would say at best we're on to pre-test 6 and maybe WebAssign, but not post-test or anything. Pre-test 6, you guys should be doing soon if you haven't already. Post-test, don't do that yet because we haven't talked about it. Let's take 5 and then we'll take, yeah, what is it? It's 12:33. Yeah, we'll spend like 10 minutes on chapter 6. We'll just spend a little bit of time on chapter 6 at the end. But let's take 5 just because we take some more than that, we'll run out of time.
I don't think so. Go ahead. Go ahead.
Are you guys ready? Jump into chapter 6 a little bit. We'll do what we can, and then we'll do a little more 6 and then 7, 8-ish on Wednesday, depending on what we get through. But what could we say? Probably chapters 1 through 4 and 5, you're all feeling pretty solid about at this point, and hopefully still amazed by the card trick. We're going to do part 3, but I have to explain chapter 6 to you. So I'm not going to make there be a due date till I've given you all the tools to know it. So we'll talk about all of this stuff. I'm not going to read it because it's kind of like learning outcomes, which I think are kind of boring. Although if you ever see me talking about learning outcomes, I'm probably having some administrator observe my class, and then I have to hit all the academic stuff. So theoretical distribution, a normal distribution, that's your bell curve. That means everything falls in the same spot. Basically symmetrical normal distribution. And that tends to approximate normal distribution, behavioral data. So it has to do with like the clustering of scores, standard deviations, variance, how scores vary. This basically how the data is what shapes what we were talking about. Skewed, normal distribution, positive, negative skew. You drew those before in terms of where the mean, median, mode fall. The central tendency basically like pulls on like the curve, basically, if that makes any sense. Like it's gonna, if it's multimodal, it's something like this. You know, if it's unimodal, it's gonna be more like the curve, and then it depends on where the mean, median, mode are, and that's what's gonna shape it. Normal distribution is literally bell curve, normal distribution. Absolutely. Wait to make sure everybody has that. Okay. So these are different means, different standard deviations. These are all bell curves. Different means, different standard deviations. Don't worry about that formula. We're really not going to use that formula. Behavioral, again, it's, I don't even like that. It's a squirrel on the x-axis with each frequency, but we're really not going to need that formula like at all. What I would probably focus, you can write down if you'd like, but what I really focus on is this. Half the data fall above or below, that's why it's symmetrical. Normal distribution is symmetrical. Above the mean is exactly the same as below the mean. The folding test, you fold it right, there, right at the top, it would have the same distribution. If you had a sheet of paper, have a perfect overlap. Got that? Okay. So mean can be negative infinity to positive infinity. It can be any value. Standard deviation can equal any positive value. Now, standard deviation can be to the left or the right of the mean. That's fine, but it's still always talked about in positive value because it's based on variance, how scores vary. It's based on the clustering behavior. It doesn't really mean anything if we say it's negative, it's meaningless. And that's just, you know, I think you're all familiar with the rule about where the scores fall percentage wise. Variability or standard deviation, you can't. It's always greater than 0. It will not be 0. Or it's not a standard deviation because it's not deviating from anything. It was to the left of this of the mean, still talk about it positive. Do that up for a few minutes. A z-score, which we'll get into, is actually standardizing another value and showing the standard deviation. Total area under the curve equal to 1, between 0 and 1. It can never be negative. I'm talking about the total area under the curve. That's what we're talking about. Proportions can be used to deal with things like probability, things happening with your tails. We'll get into that more. We'll actually say, is something actually working? If we do this or this thing, based on the z-table, the curve, the normal distribution, etc., is this thing actually happening? Is this effective or not? Greater than, less than, equal to, is this intervention working? We could take, and we'll do a different example, but we could say if someone has PTSD and they're going to a therapist, is their recovery, are they recovering at the right rate? Or are the drugs and psychiatrists are giving them working, things like that. So there's definitely applications to looking at that. Tail of the portion always approaching x-axis, never touch. All that's saying is that's your, it's not, this actually is never actually touching the tail of the distribution. So that means, and allows the possibility of outliers in the data set, like way to the left or right, or ones that really don't make any sense, outliers. Have that so far before I move on to anything else. So here's an example when I say it's the area under the curve, standard deviations. But if you have all these together, one, this is measuring each area under the curve, which we'll get into measuring that. Right now, it's just a little bit more conceptual. Standard deviations, 68% is within 1, 2 standard deviation, 95%, 95.44, and 99.72% within 3. Just like we said, you all know if you had Gen Psych, I think intelligence is the ability to adapt. But if we talk about traditional IQ scores, 100, standard deviations, 85, 70, 115, 130, and so on. Everybody's usually around there. That's your average. Most people, if you're below average, you're 1 standard deviation based on that. Or if you're above average, you're like that. And then percentage wise, you're going to go 2 or 3 standard deviations. That's why someone with an IQ of 180 or 160 is incredibly rare, because of the normal distribution of the bell curve and the data. That would be like an outlier. It also has to do with like how the measurement is too. Researchers use the word normal to describe behavior. For example, if we study obesity and sleep, short sleepers at a higher risk of obesity compared to normal sleepers. So normal is used to describe behavior. Then we can certainly have a debate on what would be a normal sleeper. Then we have to start to establish criteria, operationalize the variable, et cetera. What is normal sleep? But they're usually going to say normal behavior versus abnormal behavior, or normal sleep, short sleep, long sleep, something like that. Making sense so far? So about 5% of the data that fall within the tails are normal or likely. 95% fall about 2 standard deviations from the mean. Those are normal or likely. Again, that's that rule under the curve. These are your z-scores. Your mean is 0. And then your standard deviation 1, 2, or 3. A z-score is very easy. Z is equal to x, or your new value, minus the mean divided by the standard deviation. That's how you get an X score. We're going to practice. So this is just more conceptual today. I don't think realistically with a couple minutes of class left, we're going to have time to practice yet. We'll dive into more of this on Wednesday. So standard normal distribution, mean is equal to 0, standard deviation equal to 1. X-axis has the z-score units, which are on the bottom. Z-score is a value, and it specifies this distance from the mean, the standard deviation. So the z-score is basically converting something new to a standard deviation. And then we use that standard deviation to talk about something that we're talking about. Like I think one of the worksheets I have coming up that I created was like whether or not sending jokes around the office made employees happier and they like they're more effective at their work. But we could use a z-score to calculate something like that. And I think that was good. So normal transformation, z minus mean for the population of scores or the sample of scores. So that's basically the same formula. One is the regular mean divided by the standard deviation. The other one is the sample mean divided by the standard deviation. So all just building on what we've looked at so far. Once you know the location, you find the standard normal distribution. So let's just walk through a z-score once you all have this down, then we'll call it a day. So a researcher measures the farthest distance in feet students move from the podium during class. So someone's up here, they're presenting, and the mean or the average is 12, the standard deviation is 2. What is the z-score for x equals 14 feet from the podium? So to look at the standard deviation and convert it, you can start by sketching it, but it would be 2. Because you take 14 minus 12, which is our mean, divided by the standard deviation, which happens to be 2. So you would get 1, which is your new standard deviation from moving away from the podium. And then we'll get into the z table, which will make sense for part 3 on Wednesday, and we'll walk through z-score stuff. So any final questions, thoughts, concerns, tell me now and or as you leave class. Other than that, we'll call it a day. I hope you've learned a lot, and I hope you enjoyed the card trick. Have a great day, everybody. Yeah.